So, good evening, students. Today I am going to deal with some trigonometry. Actually, while teaching trigonometry, we find the values of certain angles in class 10. That is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Generally, while proving the values for 30 degree, 60 degree, we take equilateral triangle. The teacher explains with the help of equilateral triangle, we find out the value of sin 30, cos 30. But that means with the help of equilateral triangle, we prove sin 30, cos 30, tan 30, cosecant 30, secant 30 and cot 30. And even for 60 also, we use equilateral triangle. To find out the value of 45 degrees, we take isosceles right triangle. So I think you might have seen under the teacher explains you in the class with the help of these two. But many students ask me about 0 degree and 90 degree. How can we conclude that sin 0 is 0? How can we conclude that sin 90 is 1? So to do that one, I have one small experiment with me, and with that experiment we can conclude how do we do it. So for example, I have just my students have made this project. So dear students, if you see, you have an instrument with in my hand, actually 2 scales and 1 string. If you see, this string is making, with the help of this weight, this string is making a right angle here. It is making a right angle here. If you see here, a right angle is made with the scale. The string is making a right angle with the scale. And now if you see, and this is the right angle, and at my hand, if you see at my hand at this point, there is an angle. There is how much is this angle, that I don't know. I don't know what is this angle. But whereas if I increase, if you observe, if I decrease this angle, if I decrease this, now if you see, it is coming short. That means this is angle theta, and this side is, the string is opposite side of angle theta. Opposite side of angle theta, or you can call it as perpendicular. Opposite side of angle theta, or this is perpendicular. And if I decrease, if you observe please, if I decrease the angle, the opposite side is, if I decrease this angle, the opposite side is becoming very less. The opposite side is becoming very less. So if I decrease this angle, see here the angle is being decreased. So if I completely decrease it, the opposite side has become 0. That is, the perpendicular has become 0. Once again I am telling you see here. Once again, this is some at my hand you see some angle is there, and the length of the string is the perpendicular or opposite side. If I decrease this one, if I decrease the angle, the opposite side is also decreasing. That is, the perpendicular length is also decreasing. And if you see, I am decreasing this angle, and that is also decreasing. You observe carefully. And when this angle becomes 0, then opposite side also becomes 0. That is, the perpendicular also becomes 0. So here at the actually, what do we know? We know that sin theta is what? Sin theta is opposite side upon hypotenuse, or you can generally, some people write it as perpendicular upon hypotenuse. So here, then sin 0, in case of 0, what happened? The opposite side has become 0, that is, the perpendicular has become 0, and whatever the hypotenuse, let it be there, it is 0, and the hypotenuse is there, means hypotenuse is there. So 0, this is 0, not O, I will write it ZER 0. 0 upon hypotenuse, 0 by anything is 0. So sin 0 is 0. And in this way, we can go for cos 0. Now let us see the cos 0. Okay, let's have one more experiment with the cos 0. The cos 0, that means what I told. So if certain angle is there, when the angle is decreasing, the opposite side, that is perpendicular, is decreasing. Angle is decreasing, perpendicular is decreasing. But at the same time, if you observe, when I decrease this angle, what happens? This is base, and the opposite to right angle is, this is hypotenuse. The hypotenuse and base are coinciding with each other. That means the length of the hypotenuse and the length of the base, or the length of the hypotenuse or the length of the adjacent side. If you see, this is the head, the string is making 90 degrees angle. The hypotenuse and the adjacent side, both of them are becoming equal. When they become equal, then what happens? That means it is 1 is equal to, if I come here, cos 0 is equal to, what do we write? adjacent side upon hypotenuse, or what we write, base upon hypotenuse. But whereas here base equal to hypotenuse, base or hypotenuse, that means base and hypotenuse, they have become same. So adjacent side and hypotenuse, they have become same. That means adjacent by adjacent, it becomes same. It becomes same means what? Adjacent by adjacent means they both will cancel and we get 1. Base and hypotenuse will be both are equal. As both are equal, base by hypotenuse is what? 1. So cos 0 is equal to 1. In this way we can prove that cos 0 is equal to 1. So once if you get sin 0 and cos 0, you can calculate the value of the remaining trigonometric ratios. Now let's come to the what do we say, the 90 degrees. How to prove the 90 degrees? So dear students, if you see now, but both the scales are making 90 degrees with each other. Where is the string? You are not able to see the string. So that means what? Here if you see, now I am making some angle. When I make the angle, again you can see now that the string here, the thread is here, and now when I decrease the angle, the string is coming forward and it is becoming less. But whereas, so see, if I decrease the angle, the string is becoming less. Now if I increase the angle, it is coming nearer to the vertex. It is coming nearer to the vertex. When I go, I am going directly to the, slowly I am going towards the 90 degrees. If you see, I go to the 90 degrees. When I go to the 90 degrees, the string and the scale, perpendicular, both have coincided with each other. That means at 90 degrees, now the string and the hypotenuse, this is the hypotenuse. On my right hand here, this is the hypotenuse. Hypotenuse and the string both are coinciding with each other. That means hypotenuse and the opposite side. Hypotenuse and the opposite side, or hypotenuse and the perpendicular, both are coinciding with each other. As hypotenuse and the perpendicular are both are coinciding, that means they are equal. They are equal means if I write here, for example, sin 90 means what do you write? Sin 90 degrees is equal to opposite side of sin means what? Opposite. Sin theta, for example, if you write the formula for sin theta, definition for sin theta. Sin theta is equal to opposite side upon hypotenuse. But at 90 degrees, what is happening? Opposite side, or I will write for some students, I will write perpendicular upon hypotenuse. For at 90 degrees, what happens? Opposite side equal to hypotenuse, or perpendicular is equal to hypotenuse. Now that means what? Opposite by here, if you bring this hypotenuse to this side, you bring it to this side. So what happens? Opposite upon hypotenuse. Bring it to this side, what happens? This is 1. So sin 90 equal to opposite by hypotenuse, that is 1. And here, that means what? Here also, if you bring this perpendicular upon hypotenuse is equal to 1. So sin 90 equal to 1. In this way we can prove that sin 90 equal to 1. Now let us see the cos 90. How to do cos 90? So to do cos 90, again I am taking this one. So here cos means what? Adjacent side, that is base. Base upon, this is base, with finger I am showing, and this is hypotenuse. Base upon hypotenuse, or adjacent side upon hypotenuse. Now if I increase this angle, you see, if I increase this angle, the value of base is reducing. You see, at the beginning, the thread is here, the string is here, and when I increase this angle, the string is coming nearer to the vertex, nearer to the right angle. It is coming nearer to the right angle. You observe, it is coming nearer to the right angle. That means what? The length of the base is decreasing. The length of the base is decreasing. You see, when I increase it, when I come to the 90 degrees, it is decreasing. When I come to the exactly 90 degrees, then what happened? The base or the adjacent side, it has totally become 0. That means that the base became 0. So at 90 degrees, the base becomes 0. So that we write it here. At 90 degrees, actually cos 90 means what? Cos 90 is equal to adjacent side upon hypotenuse, or base upon hypotenuse. So at 90 degrees, what happens? Adjacent side becomes 0. Adjacent side is 0, or base is 0. Base equal to 0. So then cos 90 equal to, now you put this is cos theta, the definition. Cos 90, if you see here, what happens? Adjacent upon hypotenuse, that is adjacent is how much? 0. 0 upon hypotenuse, so it is how much? 0. Or base upon hypotenuse, that is base is 0. 0 upon hypotenuse, that is 0. In this way, cos 90 is also 0. Sin 90 is 1 and cos 90 is 0. With the help of these two values, we can find out the remaining values. Actually friends, here I want to just tell you that we can make mathematics very easy. If you study logically in this way, everything we can understand properly. So that means that we can do everything practically. Mathematical is a logical subject which can be proved with the sources that are available to us. Thank you for watching this one.